So, continuing our notes on Chapter 4 about converting between units. Again, we're talking now about our more complex problems. In our more complex problems, we might have to do a multi-step problem. Basically, multi-step problems, you just have to break it down into smaller, manageable parts. When you do this, it's often necessary to use more than one conversion factor, meaning that you will have to string several conversion factors together. When you are converting complex units, you're going to tackle each unit separately. And because you're multiplying and dividing, the order in which you tackle those is up to you. Because the order of multiplication and division doesn't matter. So we're going to do 2 example problems. For our first example problem, the density of manganese is 7.21 grams per cubic centimeter. We want to know what the density of manganese is in kilograms per meter cubed. So again, this is a more complex problem because we need to change grams to kilograms, and because we have to change cubic centimeters to cubic meters. So that's what makes this a more complex problem. Again, part of the trick of starting with this, is that you want to make sure you know which units in the numerator and denominator. So, when I start this, I'm going to start with 7.21 grams over cubic centimeters. And again, I have 2 things to do. I need to change grams to kilograms and cubic centimeters to cubic meters. It does not matter which one you do first. So I'm going to do the grams to kilograms first. Because grams is in the numerator, grams has to go in the denominator, and I'm going to change it to kilograms. Now, if I stop right now, I have kilograms per cubic centimeter, which isn't what I want, but I'm getting closer. A kilogram is larger, and it's 1,000 grams. So now I need to change cubic centimeters to cubic meters. Now, centimeters is in the bottom, so I need it to be at the top. And I don't necessarily know something about cubic centimeters and cubic meters, but I do know something about a centimeter and a meter. I know that a meter is larger and that it's 100 centimeters. However, I need cubed. That's the problem. The way to fix that is to cube this whole conversion factor. Now, because my cube is on the outside of my parentheses, I need to bring it inside my parentheses, which means I have 100 cubed, centimeters cubed, 1 cubed, meters cubed, and I've gotten rid of that cube. So now, my answer is in kilograms per meter cubed, which is what I wanted. So now I just have to do the math. I need to take 7.21 and multiply it by 100 cubed, and then divide that answer by 1,000. When you do that, you should end up with an answer of 7.21 times 10 to the third kilograms per meter cubed. Our second problem says that there are 7.0 times 10 to the sixth red blood cells in 1 millimeter cubed of blood. So our question is, how many red blood cells are in 1 liter of blood? So in this problem, I'm asked to take 1 liter of blood and figure out how many red blood cells. So that means, again, this information here is given to us to use as a conversion factor. The given that we want to start with, okay, is this 1 liter. So we're going to start with 1 liter. Again, to use my blue conversion factor here, I have to be in millimeters cubed. So I'm going to go from liters to milliliters. And a liter is 1,000 or 10 to the third milliliters. Now remember, I told you there was a conversion factor you had to remember, which was that a milliliter and a cubic centimeter, okay, and they were a 1-to-1. Now I know something about centimeters and millimeters. 1 centimeter is 10 millimeters, but again, I need it cubed. So cube, 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 cube. So again, I'm in millimeters cubed. I need red blood cells. So now I'm ready for that conversion factor. Millimeters cubed to red blood cells. 1 millimeter cubed was 7.0 times 10 to the sixth red blood cells. So now I'm ready to do the math on this problem. So this is one that you need to put into your calculator so that you can do this. So you should be putting this in your calculator and making sure that you're able to get the answer, okay, of red blood cells, which is 7.0 times 10 to the 12th. Again, 7.0 because I need to have 2 significant figures. So that wraps up our notes on Chapter 4. Hopefully now you see how to set up these problems using these conversion factors.